Hello, in this video we're going to talk about calorimetry, heat and calorimetry. So the first two problems in the playlist that we have, we talked about how to find Q. So they said how many joules are needed to warm a certain amount of water from a certain temperature to another temperature. And so basically we use the formula M times C times delta T. But what happens in a question like if 1.13 times 10 to the fourth joules of heat is added to a water sample and the temperature rises from 88 degrees to its boiling point, what mass of water is in the sample? So now we're looking for the mass of the water. Well, how do we go about that? Well, what we do is we basically write down the units we've been given or that we know. We know what C is, we know what Q is, we know what T initial is, and we know what T final is. How do we know the final temperature is 100? Because they said it goes up to the boiling point of water. So notice that in science, sometimes you need information, prior knowledge to help you navigate the problem before you. So that's how we find T final. So basically, Q is equal to mass times C times delta T. Delta T is the T final minus the T initial. So I had written this problem earlier. I apologize. I forgot to hit the record button didn't work earlier, so that's why the work is already on the board. But I'll just guide you through each step of what I did. So basically, Q is equal to M times C times delta T. And so Q is, we divide both sides by C times TF minus T initial. Why? Because we're solving for M, right? So notice we're doing some algebra here, solving literal equations. So we divide both sides by those values, we divide both sides, and we get M is equal to Q divided by C times the final temperature minus the initial temperature. Now we come down and we plug in our values. We have 1.13 times 10 to the fourth joules divided by the values that are given in the denominator. 4.18 joules per grams degree Celsius, and then we have 100 degrees Celsius minus 88 degrees Celsius. 100 minus 88 is 12. And so we get 1.13 times 10 to the fourth joules divided by 4.18 times 12. If you have a calculator where you want to put a parenthesis, so you put this value and then divide it by this with the parentheses, that will bring you to this point. Or, well, you could just choose to do the denominator first, get 54.34. You divide the numerator divided by the denominator, and that will give you 225 grams. So that's how we get our answer for finding the mass. So all we had to do was rearrange the formula to find the mass. And then it brought us to this point, and we plugged in the values, and we got the answer that we need. Number 4 in our worksheet that we're using as a review, we found this worksheet online, and I'm just using it as a resource for learning how to use the formula. They said the specific heat capacity of gold is equal to 0.128 joules per grams degrees Celsius. How much heat would be needed to warm 250.0 grams of gold? Right? That's the symbol for gold. From 25 degrees Celsius, so that's your initial temperature, all the way to 100 degrees Celsius. So we write down the values that we've been given. We have the mass, we have C, we have mass, we have T initial and T final, and we plug it into our formula. M times C times delta T, which is Q is equal to, let's see, 250.0 grams, times C, which is 0.128 joules per grams degrees Celsius. And then we do the final, 100 minus 25 degrees Celsius. So that becomes Q is equal to this times 75. So 250 times 0.128 times 75, okay? Q then would equal the value there. So the specific heat capacity of gold is given. How much heat would be needed to warm 250 grams of gold? So we're looking for how much heat would be needed to warm it. So your temperature here is going to be, you need to know whether it's going to be positive at the end, and it's going to be positive because we need that heat to come in to raise the temperature from 25 degrees Celsius to 100 degrees Celsius. If you do all the math correct, your answer here will be 2.4 times 10 to the third joules. Again, scientific notation is very important. In the third problem here, we did, we're given all the values except the mass. We used the equation solving skills to get the mass. In this problem, we basically were given all the values, but it was for gold. We didn't use the same C for water because it's gold, of course, in this problem. Let me know if you have any questions. Keep up the good work, and we'll see you in the next video.